Hi everyone, and welcome back to 360DigiTMG's Domain Analytics program. I hope everybody is doing great. So, since a couple of days, we are discussing the domain that is called banking and insurance analytics. So, what exactly the banking and insurance analytics, and what we will be doing in banking and what we will be doing in insurance? We have discussed few use cases. If you have followed those videos, in that case, you might have an understanding. So, what kind of predictive modeling that we can do, and in the very first day, we have discussed, right, what are the applications we'll be having when it comes to banking and insurance analytics. So where exactly we can do the improvement using the machine learning that we have seen using the machine learning and AI applications we have seen, and how we will be doing the pre-processing, what are the CRISP MLQ methodologies, cross industry standard process, quality assurance. So it is the standard process. The phases we can see, we can say that is a process we are supposed to follow in order to do the data science project, or you can say in order to improve the accuracy of the model. So we need to follow some hierarchy. For that, we have CRISP MLQ that we have seen in detail. And when you are receiving the data, maximum, most probably you will be receiving the data in the form of raw form. Raw form, in that case, you might be having any like number of anomalies. So what are the anomalies we'll be having? Various anomalies, and how we can do the pre-processing for those. Pre-processing in the sense cleaning of the data or data cleansing, or we can call. So various names we'll be having. So we have gone through all these things, and then we have seen what are the models we'll be having. Supervised model, semi-supervised. So that is not, now upcoming thing, that is semi-supervised. So it is a mixture of both supervised as well as unsupervised. And what are the unsupervised? So what is the difference between those? So in detail we have discussed. So in that supervised, what happens? How the process works? So first, what we'll be doing right after the pre-processing, we'll be feeding the data, the whole structure, whole process, what happens when it comes to supervised. That is, we have discussed. And then unsupervised, what exactly the unsupervised? So what is the process we will be having when it comes to unsupervised? That is also we have discussed in detail. Once it is done, we have seen unsupervised learning algorithm, in that K-means algorithm, most popular algorithm when it comes to unsupervised. Segmentation, clustering. So we have discussed what exactly the K-means is and how we can apply this K-means in real-time scenario. Use cases we have seen, right? So that is a real-time scenario, how we can apply this K-means algorithm. So that we have seen, and then when it comes to supervised, various algorithms we have discussed, like simple linear regression we have discussed, or you can simply call it as linear regression. So we have discussed about the decision tree. We have discussed K nearest neighbor. K-NN algorithm we have discussed. So like that, we have discussed various algorithms, and we have applied these algorithms, these supervised models in use case. Each and every model we have taken use case. Decision tree we have taken 2 use cases, and we have seen how we can apply it in the real-time scenario. So these are the things that we have discussed till now. So if you haven't watched any one of these, in that case, I highly recommend you guys to go through it. So if you are interested in the banking and insurance analytics domain, banking and insurance domain, in that case, I highly recommend you guys to go through those videos. So yeah, So that is all about what we have discussed till now. So what are we going to discuss today? We'll see in detail before that. So we have discussed what are the algorithms that we have discussed. We'll list down. First, simple linear regression, that is linear regression you can call. And decision tree. And it is a k-means. So it is unsupervised, it is also one model. Decision tree, and what else we have? KNN. KNN also we have discussed. K nearest neighbor. Today we will be discussing about logistic regression. Don't let that name confuse you guys. Logistic regression. Logistic regression. That doesn't mean we are supposed to use for the regression. Especially the logistic regression will be used for classification. Logistic regression used. That is the reason. Name, it is saying regression, but it is used for the classification. How it will be used? So what is the mathematics behind it? So how it is different when it comes to other regression techniques, and why it is used for classification, how we can convert that regression output into the classification, that we will see in today's. In today's session, all these things we will be discussing. And at the end of the session, we will be taking one use case scenario with respect to the banking and insurance domain. And we'll see how it can be applied this logistic regression when it comes to real-time scenario. So before that, we have, so in order to understand the logistic regression, you have to have a good understanding about the probability distribution. In probability distribution, so what exactly the probability distribution is? When it comes to probability distribution, how many types we have? So we have continuous and we have a discrete probability distribution. What exactly those we'll try to understand. And then we'll be having simple logistic regression. Instead, we'll be taking the multiple logistic regression. So let me change it here itself. Multiple logistic regression we will be having. So what exactly that is? So instead of using simple one input, we will be using the multiple. That is, we'll be calling it as multiple logistic regression. We'll see one use case scenario and then we will evaluate. So how we will be evaluating and how ROC curve will be helpful, that we will see in today's session. So this is agenda, you can say. First, we'll understand what exactly probability distribution is. So sum of probability. Let's say, yeah, you are selling iPads. On first day, you have sold 0 iPads. Second day, you have sold 3 iPads. Third day, sold 5 iPads. Fourth day, 0. Fifth day, again 3. Sixth day, again 5. Something like that. Yeah. So what is the probability of iPads are getting sold 0? So what exactly probability is? Number of favorable outcomes to total number of outcomes. So what exactly we are doing here? So number of favorable outcomes when it comes to the statement that I have called it, the number of iPads getting sold is equal to 0. So if you are considering only this, in that case it is 0. How many? 1 and 2. 2 by total number of how many we have? 6. If you are considering number of iPads are getting sold, that is 3. How many we have? Again 2 by 6 we have. So 3 and 3. So iPads getting sold, that is 5. Again we have 2 by 6. So if you sum all these things, in that case, how much you will be getting? 1. Sum of the probability, it is always equal to 1. Sum of all the probability, that is always equal to 1. So if you represent this data into the histogram, so how much it is? 2 by 6. So 1 by 3, 0.33 you'll be having. So here also 0.33 you'll be having 0. When you represent this here with respect to 0.33, all will be the same. All will be the same. So whatever the sum of the probability we will be having, that is 1, we will be distributing into individual events. So whatever the sum of the probability will be having, that is 1, we will be distributing into individual events. That is, we will be calling it as probability distribution. That we will be calling it as probability distribution. Like that, here we have discrete data it is. Here we have discrete data. So when you have a discrete data, that distribution will be calling it as discrete probability distribution. When you have a discrete data and that probability distribution, we can call it as discrete probability distribution. Instead of this number of iPads, if you take price, let's say $240.5, that is iPad. $230.5, something like that. So it is a 1 iPad price. In that case here, 0 will be getting into 3, 240.5. So into 5, into 3 will be having into 5. So if you consider this data and if you do this graph, in that case, you will be getting the continuous probability distribution. In that case, you will be getting the continuous probability distribution. So these are the difference when it comes to discrete probability distribution and the continuous probability distribution. So these are the main differences we will be having. So you can see here the number is some count value will be having, right? Count value comes under discrete. And here we'll be having, it is continuous distribution. So this represents the discrete distribution only, but if you draw a line, in that case, this line represents continuous probability distribution. This continuous probability distribution. So I hope you have an understanding between now you have an understanding between the continuous and discrete probability distribution. So what exactly the logistic regression? What are the different types we'll be having when it comes to logistic regression? We'll see. So logistic regression is 2 types. That is one simple logistic regression, and then we'll be having multiple logistic regression. It is similar to the simple linear regression and multiple linear regression. MLR and SLR we'll be having, right? Similar to that, we have simple logistic regression. When it comes to simple, just have one input, and the output is probability. A single independent variable model is called simple logistic regression. When you have just one, in that case, we'll be calling it as simple. When you have multiple inputs, a multiple independent variable. Independent means input, features, or input columns, all comes under independent variables. Model is called as multiple logistic regression. So these are the 2 types of regression techniques will be having. Logistic regression will be having. So what exactly the logistic regression, how it is different when it comes to linear. So you can see here, logistic regression model predicts the probability associated with each dependent variable category. We have seen, right, those number of items are getting sold, how many. So individual probability distribution it is talking about. individual probability distribution. How does it? How it is happen? It finds linear relationship between the independent variables and a link function of the probability. Then the link function that provides the best goodness of fit for the given data is chosen. Let's say, so here, when it comes to linear regression, what we will be having the value below 0 and we have above 0. So when it comes to logistic regression, each and every have one probability. Each and every dot, every point will be having a probability. It represents the probability. So let's say we'll take one example. Let's say in order to one particular person, a candidate, to pass. Here we have just two. If below 0, in that case, fail. Above, in that case, it is pass. But here, the moment it is start increasing, the probability become a to pass that particular exam. How much probability will be having? Here we have some less probability. Here we'll be having some more probability. Like that, probability will be keep increasing. So here, what we will be doing when it comes to logistic regression, we are simply making one cutoff value. Making one cutoff value. If the value is beyond that, in that case, we'll consider as one class. If it is below that, in that case, we'll be considering as one more class. So it is 0 class, in that case, it is 1 class, it is 1 class, in that case, 0 class. So like that, whatever the probability will be having, logistic regression, this is how it will be converting. So here, each and every data, individual data will be having, same data will be having here, but we are converting into 2 classes. The number of classes you want, you can simply convert based on the data. Here it is not the case, but individual data will be having, but here the same data will be having, but we'll be converting using one cutoff. So what the cutoff we will be calling as optimum value. So what exactly that optimum value also we'll try to understand. So in order to understand regression, we need to have a good understanding about. So what is a correlation? So what exactly the correlation is? The relation between the two data points, to numerical or to continuous also called. So we will be using this scatter plot to understand that correlation that is in between the two variables. Scatter diagram provides a plot, provides a graphical representation of two continuous variables. So here we'll be having one and here we'll be having. So whatever the data points we'll be having, we'll simply represent in XY plane. So here we have XY plane. If you draw a line, all the data points are along that particular line. All the data points are along that particular line. In that case, I'll be calling it as strong correlation. Along means on. In that case, I'll be calling it as strong correlation. So here, if you draw the same line, most of the data points are not on that particular line. So I'll be calling it as moderate. So irrespective of X and the values of Y are also same. In that case, we doesn't have any relation. So no correlation. So if it is X is increasing and Y is decreasing, in that case, I'll be calling it as negative. Since all the data points are not, most of the data points are not present on that particular line. So I'll be calling it as moderate. I'll be calling it as moderate. And then we have strong negative correlation. If most of the data points are on that particular line, in that case, I'll be calling it as strong negative. And it is not just about the linear relation. We can have non-linear relationship as well. Non-linear, it is curvilinear relationship. So like that, we'll be having. So these data, whether it is strong or moderate relation we have, or no relation, it is subjective. So for this, I might be calling it as moderate. You might be calling it as strong. So it depends on the perspective of the person. So I don't really, in that case, so it is different, subjective. So what we will be doing, we'll be converting this relation, what kind of correlation we'll be having into numerics. So we are quantifying that relationship using correlation coefficient. We are quantifying that correlation using the correlation coefficient. So now we will be getting the values. If the value is greater than 85, 0.85, in that case, I'll be calling it as strong correlation. If it is less than 40, 0.50, in that 40, in that case, I'll be calling it as weak. If it is in between those, in that case, moderate correlation we can call. So it is a correlation in between the two variables, two continuous variables to be specific. Scatter diagram provides our plots, provides normally a scatter diagram means when you are having two continuous variables, in that case will be getting. So it is pretty much similar to the linear regression. So when it comes to linear regression, we'll be having just one input. When it comes to multiple linear regression, you'll be having multiple inputs. Similar to that, multiple linear regression and simple linear regression will be having simple logistic regression and multiple logistic regression. Multiple logistic regression model is quite similar to the multiple linear regression model. Only this coefficient beta will change. So beta values only will be changing. Other than that, all the same will be having. These are the input values, input features you can call, and here beta will be having. So beta naught. So it is that these are the coefficient beta 1, beta 2, beta 3, something like that. The number of inputs will be having that many coefficients will be having, and the very first one will be calling it as constant, or you can say y-axis intercept. So the model coefficient for the linear affect the variable. So these are the inputs, various inputs, and with respect to their coefficients. So similar to the multiple linear regression, will be having it. Similar to that will be. So whatever the outputs, here you can see the y is equal to prediction, right? So similar when it comes to multiple linear regression, how we'll be having y is equal to same. We'll be having beta naught plus beta 1x1 plus beta 2, x2 plus beta 3, x3 will be having. But here the coefficients and here coefficients are very different. So same equation will be having. So this equation will be giving you probabilities. This output it will be giving. That output we are simply replacing here. So to convert into the probability, to convert into the probability, whatever the output that we are getting, that is y, beta naught plus beta 1x1 plus beta 2x2. This value, this y output value will be simply replacing here. So in that case, whatever the value that we are replacing, you will be getting the values, the output in the form of probability. So probability in the logistic regression curve. So using this equation, we will be getting the probability values. So you can see E is the real constant number, basic natural logarithm. So this is the constant number we'll be having, and Y represent the value. So that output, the prediction that we have made, that output will be simply substituting here. So when you substitute, you will be getting the values of probabilities. So based on those probabilities, we will be deciding the optimum value. You will be deciding the optimum value. What is the optimum value? That we will see in a minute. So based on that optimum value, we'll simply find out if it is greater than that optimum value, whatever the value that we are getting. If it is greater than the optimum value, in that case, I'll be calling it as one class. That could be 1 or 0 class. And if it is less than, in that case, I'll be calling it as 1 or 0 class. So logistic regression, various methods will be having based on the output, the kind of output you will be having, whether it is simple, you don't have any order, or if you have two classes, in that case we'll be calling it as, we'll be going with one logistic regression. If it is having 3 classes, in that case we'll be going with some other. So like that, we have various different logistic regression models. We'll see what are those. Binary, when you have output, description of categorical response variable. When you have just 2 categories, in that case, I'll be calling it as binary logistic regression. Presence and absence, and you can say true and false, or whether that particular person has cancer or not, benign and malignant, something like that will be have various cases, right? Binary, when you have just 2 categories. Nominal, 3 or more categories with no natural order. When we are talking about the nominal data, you don't have any order. Like, crunchy, mushy, crispy. So this doesn't have any order. So in that case, I'll be going with nominal logistic regression. When you have a output categories or output classes are 3 or more than 3, in that case, we will be going with nominal logistic regression. And here the output kind of output will be having crunchy, mushy, and crispy. When it comes to ordinal, so same 3 or more categories will be having as an output, but it has some natural order with it. So those classes have not natural order. In that case, we'll be going with ordinal logistic regression. In that case, we'll be going with ordinal logistic regression. In that case, we'll be going with ordinal. So here you can see strongly disagree, disagree, neutral, agree, strongly agree. So these are all having some order. If I tell you to sort this, in that case, we'll be having some order. In that case, you can sort it. Let's say I'm giving you, these are the things I'm giving. Extra small, XS, extra small, small I'm giving, XL I'm giving, medium I'm giving, large I'm giving, double XL I'm giving. If I told you, if I tell you to sort this, in that case, it is having some natural order. In that case, based on that, we'll be sorting it extra small, small, medium, large, and XL. So it is having an order. In that case, we'll be going with ordinal logistic regression. So these are the various regression methods we'll be having. So whatever the p-values that we are getting. So y-value, how we'll be getting this value when you are using just simple linear regression. In that case, it is a constant we'll be having, and this is the coefficient, that is beta 1 we are talking about, right? And into x, if you have some inputs, so input features will be having it very first, let's say, based on waste and predicting the adipose tissue, how much amount of adipose tissue will be having. In that case, we'll simply giving waste in place of x. Based on that, we'll be predicting this y. So p-value indicates that there is the insufficient evidence that rejects the null hypothesis. So normally, so whatever the when you are getting this y value using this, So that is y is equal to beta naught plus beta 1x. When it comes to simple logistic regression, we'll be using that equation. And whatever the value that we are getting y, if you are replacing or if you are substituting that value into this, in that case, we'll be getting p values that are, we'll be calling it as probability values. So based on those probability values, we will be predicting this output. So how we'll be doing that? You can see here. You can see probability values are keep increasing, right? So let's say what is the probability that particular person, if he started, so here it will be 0. Let's say one person is preparing for an exam, and here he didn't prepare anything. So in that case, what is the probability that particular could pass? 0. If he starts preparing for that, like let's say 20 minutes, 25 minutes, if he is preparing, in that case, probability with respect to passing is keep increasing. So here, keep increasing when time is increasing. So here we can say that amount of time he is taking to prepare, in that case, probability to pass, it will be keep increasing. So at one point, we will be having optimum value. Optimum value, what exactly the optimum value we'll see in a minute. So if the value, optimum value is greater, if whatever the probabilities that we are getting, if it is greater than those optimum values, in that case, it will become one class. If it is less than that, in that case, it will be one class. Here in this case, if it is greater than the optimum value, in that case, that person can pass the test. If it is less than that, in that case, so we need to have at least some time. I mean, this much of time you have to spend studying. In that case, only you'll be able to pass the test. Something like that we are deciding. That is, we'll be calling it as optimum value. That is, we'll be calling it as optimum value. So once that classification is done, so based on the optimum value, we are deciding it. So which is one class and which is one another class. So whatever the class that we are getting, it is similar to now class, classification. So whatever the output that we are getting after the logistic regression, so we will be getting, let's say, binary classification. In that case, zeros or one will be having yes or no, something like that will be having it. So whatever the output that we are getting, now we will be evaluating using the confusion matrix. The same confusion matrix when you are using decision tree, when you are using the KNN classification, decision tree classification, same confusion matrix will be using to evaluate the model. To evaluate the model, we will be using the confusion matrix. Let's say here, true positive. If both predicted and actual, both predicted classes and the actual classes are same or positive, in that case, we'll be calling it as true positive. Actual and predicted cases, both are true. In that case, we'll be calling it as true positive. If actual and predicted cases, both are negative, in that case, true negative. Patient with no disease and told that he is not having any disease. Actual and predicted, both are negative. Patient doesn't have a disease, and the prediction also it is saying it doesn't have a disease. In that case, we'll be calling it as true negative. And here we'll be having false negative. Patient has a disease. Patient has a disease, but we are saying that our prediction is saying that he doesn't have a disease. In that case, it could be a detrimental case. So whenever we are dealing with the medical life sciences data, we have to be extra careful about this false negative cases. Patient has a disease, but you are saying that he doesn't have a disease. In that case, it could be a detrimental, right? So he will be relaxing, saying that I don't have a disease. So in that case, it will affect him very badly at the time. I mean, when the treatment should be done and you are not able to do it, in that case, it will get worse, right? So he might be in very first stage of that particular disease. And if you are saying that false prediction, so he is getting relaxed, and after 5 months, eventually he has to know, right? What I mean, eventually you'll come to know you would be having disease. In that case, it might be getting too late. So in that case, we need to be extra careful. And then we have a false positive patient with no disease, and we are predicting has that particular person has a disease. So these are the 4 cases we'll be having. Based on that only we'll be deciding the accuracy of the model. So what is the accuracy of the model formula? All true cases by total. All true cases plus by total. So what will be true positive plus true negative by true positive plus true negative, false positive plus false negative. So these all comes under accuracy. This will be calling it as accuracy. So when it comes to error rate, 1 minus accuracy itself, error rate, right? So completely different. False negative plus false positive by all. So that will be calling it as error rate and the accuracy. So this is how we will be finding out what is the accuracy of the model and what is the error when it comes to the model. So how we will be deciding that optimum value. So using the ROC curve, receiver operating characteristics. So you can see, right? True positive, true negative, this false positive and false negative. So you can see when this curve, it reaches that corner, in that case we'll be calling it as perfect classifier. So that means 100% accuracy, but in reality it doesn't happen. So we have to come up with some model that goes as near as possible, so that we can increase the accuracy of the model. We can increase it. So we have to look for the data, look for the values where false positive rate is as less as possible. So here we have 0. False positive rate here we have 0. In that case, 100% accuracy. So this will be calling it as perfect classifier, but it is not the case. So what we will be trying to do, we'll try to decrease this false positive rate as much as possible, and the true positive rate will try to increase as much as possible. So somewhere like this, we'll be getting that value. So this value will be calling it as optimum value, where false positive rate is least and the true positive rate is maximum. That difference will be getting as optimum value. So using that optimum value, if the values are beyond that optimum value, greater than optimum value, in that case I'll be saying one class. So if it is less than that, in that case I'll be calling it as the remaining class, when you are going with the binary classification. So like that, we will be deciding what could be the optimum value. So how we'll be deciding that? We have to decrease false positive rate as much as possible, and true positive rate we have to increase as much as possible. That combination, wherever you are getting the optimum value, is maximum. So that we'll be considering as optimum value. So like that, we will be coming up with optimum value. So we'll see one use case scenario and how we will be implementing the logistic regression. So how it is different from the linear regression when it comes to implementation. So those things we will try to understand using the code. So before that, I'll be going through what exactly the business use case we'll be having here. So yeah, one bank is facing surge when it comes to NPA. A bank is facing surge when it comes to NPA, non-performing assets. Let's say some particular person took a loan. Some particular person took a loan, but he is unable to pay back. In that case, that will be calling it as NPA. So to deal with that, we are coming up with one model. So using what we'll be doing, we'll be predicting whether that particular person gonna default the loan or not. So if you know that upfront, in that case, whether you want to approve the loan to that particular person or not, you'll be deciding. So in that case, we can reduce the NPS a little. In some extent, they can able to restrict those. So yeah, without wasting any time, we'll get into the coding and we'll try to understand. So I'm importing the necessary libraries. Pandas that I need, Seaborn I've been needing, Matplotlib also I need. I'll whenever I need, in that case, I'll be importing those. So import NumPy and Pandas. Pandas why we are using in order to do manipulation in your data frame. Pandas. Manipulations in data frame. In that case, I'll be using that NumPy, numerical calculations, and we'll be having Matplotlib. Matplotlib in that case for the visualization. And then we have SNS that is also called as Seaborn. So for the advanced visualizations, C and sklearn. Scikit-learn also you can call. Most of the models, whatever the models that we will be using, that are with the sklearn library. So you can see here from sklearn only I'll be importing the train test fit, and from sklearn using sklearn only in linear model I'll be having the logistic regression, and from sklearn only the pre-processing label encoder, standard scalar, min-max scalar, all most of the that is a heart of data science. So most of the libraries will be present with sklearn. So I'm simply loading the data, that is training data.csv. So here I'm using, you can see, yeah, you can simply run, and you can simply run this. So training.csv, I'm importing the training.csv. What are the data we'll be having? I'm simply transposing it. In that case, whatever the columns will be having becomes rows, rows become columns, just to know what are the features I'll be having. ID, income, age, experience I have, married, single, and a house ownership, whether it is rented or owned, car ownership, whether they have their own car or not, current job, how long he's been working, current house years, risk flag. I mean, it is an output. We can target this, target feature, you can say, label data, you can say. So these are the features I'll be having. Based on this, using these, I have to predict whether that particular person gonna default the loan or not. So income, it is an important factor, but ID, it is not important. Age, it could be an important factor. Experience, it is important. Married, single, so it can be important. We'll see EDA whether it is having any importance or not. House, it is important, and car ownership, it is also important. Like that, we have various features. So what I'm doing here, I'm simply checking what is the shape of the data. 250,000 entries I'll be having, and 13 rows I have. 252,000 entries I have, and columns we have 30. So I'll be looking into the data a bit deeper. So info, it will tell you what kind of data types it is holding. So all the data types, various data types will be having. You can see null values, non-null values. How many? 252,000. Here it is also 252. Here also 252. Here also we have 252. Like that, we have various. So it seems like we don't have any null values because all the values are present. 252,000. Integer, object. So what kind of data type it is holding also it will tell. So how much memory it is occupying, that is also will tell you when it comes to data.info feature, info function. So here looking at if we have any duplicates or not, and we don't have any duplicates. And city and state, it is nominal data. It won't give you much information. So I'm simply dropping those features. Data drop, city and state. Since it is a nominal data, right? Here you can see city and state. So based on just because he is from Rewa, Parbhani, Alappuzha, so various cities will be having. Based on the city itself, are we can we say that we have to give loan to that particular person, or we can say that he is going to default the loan. So we can't say just based on the city or state, Madhya Pradesh, Maharashtra, just because he is applied from Maharashtra. We can't say right whether that particular person is going to default the loan or not. So it is not possible. So I'm simply dropping those features. So you can see here, print the data set. Yeah, here data.drop city state. So I'm simply dropping in place is equal to me. Whatever the update data will be having, it will be updated into data frame, that is data. So exploratory will try to do some exploration when it comes to data. So what kind of insights we'll be getting, we'll try to understand. So why do we need to do the EDA? In that case, you can come up with a better model. So you'll be getting more understanding about the data. So we'll do that. We'll do exploratory data analysis. So you can see here data.columns. So what are the columns left? So we have ID, income, age, experience. These are the various data that are left after removing that city and state. And here you can see, I'm simply renaming that married and single data I'll be having it. Instead of that, I'm simply creating a marital status. So it doesn't look good. I mean, just I'm changing. If you want to change in that case again, or else let it be. So I'm simply changing the marital status. Instead of married and single, I'm simply changing the marital status. In that we have single and married, right? Anyway. So these are the records when after doing the rename. So these are the income and age, experience, ID we have. It is not required for now. Marital status, whether it is single or not. House ownership, rented or not. Rented or own ownership will be having. Car, whether that particular person has a car or not. Just yes or no. Profession, what kind of profession that he belongs to. Mechanical engineer, software developer, technical writer, software developer, civil servant, like that we have. City, state. So if you want to drop it, in that case, you can drop it. I have already dropped it. Okay. So here we'll be having categorical data. So whatever the categorical data we'll be having, model won't be taking directly, right? It won't take the data directly. So textual data it won't be taking. So what we have to do? We have to convert into numerics, or you can simply convert into the zeros and ones as well. Monad encoding, label encoding, various encoding techniques will be having. So let's see how we can do convert this categorical data. Before that, we'll see what kind of correlation we'll be having in between all the features. These are the output, risk flag is the output, and with respect to others. So you can see, so here we have current job years and experience. Obviously, it is pretty much same, right? Current job. So if you have more current job years, in that case, that many experience will be having. So it is obvious. So we'll be having a good, correlation when it comes to current job years, and not exactly same, but you will be having good correlation. So about 67 and 70% will be having correlation, but it is okay. We can go ahead with that particular one. It is not that much. Okay. So here you can see we are plotting the SNS not defined. Okay. I don't want to run that one. So let's see. We will be doing the analysis. Let's see if the house ownership has effect. So when you are doing the exploratory analysis, we will be going through each and every perspective of the data, and we'll try to understand, can we find anything. So here, rented, and what is the risk? If it is rented, in that case, what is the probability of getting the loan? If it is owned, in that case, what is the probability of loan? You can see here, the people who have rented has more chance to get a loan. See, people who are having zero risk and people who are having the risk. So you can see people who are having the rented, yeah, for those people only having a chance to get a loan. It is some interesting insight, right? Similar to that, here what we will be having, if the ownership of the car, the people who has no car ownership has a less risk. So if you are having the car, in that case, is it affect to pay back the loan? So that is we are trying to assess. People who has no cars ownership has less risk. If it doesn't have a car, in that case, we don't have much risk compared to the people who are having the car. So that is exactly what that means. And here, profession and what is the risk? So what is the profession, and with respect to that particular profession, what is the risk of not paying that particular loan or might default? So these are, so it is analysis for that profession and the risk plan. So mechanical engineer, and with respect to that risk, software developer, yeah, seems like good. Police officer in that case. So various we have the profession and their respected risk. So now I'll be doing so these are the visualization, and you have a visualization. In that case, you can come up with few inferences. What exactly the data is. You will try to understand the data more. And you can, when you do the exploratory analysis, in that case, you can come up with a better model if you have a good understanding on that. So once it is done, we have to go with the pre-processing. So like I told you earlier, whatever the data will be having, most of the data are categorical. So when you have a categorical data, it is not possible to feed that particular categorical data directly to the machine learning. Instead of that, what we have to do, we have to convert the data into discrete, or you have to do the encoding. So this is data we'll be having, and wherever I have categorical data, I'm trying to create a dummies. So you can see I have created the dummies for marital, or you can simply go with 100 encoding as well. Marital status, house ownership, and house ownership owned or no owned, single, married. So when you are creating dummies, in that case, you will be getting something like this output. Underscore unique values, main title with underscore and unique value, something like that we'll be having for dummies. So again, we'll be having the data, main data, and simply concatenating both. So this one and this one I'm concatenating. Once it is done, we have order data, right? Kind of order data only, profession. So various professions will be having, and with respect to that individual profession, it will be having various other characters. So what I'll be doing, I'll simply do the label encoding for the profession. And there is it. So here you can see for profession, I'm doing the label encoding. So after encoding, I'm simply storing into DFR encoding profession. Same, I'm trying to concatenate in this encoded profession. So these are the this many profession will be having 47, 43, 33, something like that. We have various professions. So once it is done, the whole pre-processing is done. In that case, what we'll be doing? It is supervised drill. Supervised algorithm. Whenever you are talking about supervised algorithm, we have to go through this process. First, we'll be having 100% data. So whatever the 100% data will be having, we are simply splitting into the train and test. We are splitting the data into train and test. So using the train data, we'll be training a machine learning model. Using the test data, we'll check how this machine learning model is working. So how many ways we can do the test, the splitting? 70%, 30%, 80%, various ways we can have. It based on the number of data inputs we'll be having, number of records we'll be having. Let's say have 1 million records. In that case, I can simply go with the 90% as the train and 10% for test. So it depends on the how much amount of data you'll be having. Based on that, you can go with. Here I will be having 2,52,000, right? So I'll be going with 30%. How much we are giving? That is the data. Yeah, 20% I'm giving for test and 80% data I'm giving for train. So that is we'll be calling that splitting the data, train, test, split. So what exactly that we'll see. Splitting the data for the model. So we have to categorize which is output and which is input. Which is output and which is input. You need to have a good understanding about it, right? Input as well as output. So in this input, what we have other than this risk flag. So risk flag is a targeted variable. So here, risk flag is the targeted variable. Yeah, risk flag is the targeted variable. Other than those, all comes under input. DF, that is I'm storing in variable X. Whatever the values other than the risk flag, I'll be considering into X variable. And if it is risk flag, the output, so that is I'll be considering into Y. So it is input, X is input, and the Y is output variable. So when you go through the data, in that case, income, how much we have? 130, 1.3 million, something like that will be had. So experience, this is a range. Current job years, this range. Current house, how long he's been, you've been into that particular place. So it is in years. Risk flag, it is a targeted variable. Marital status. So zeros and ones will be having. So these many values will be having. In that case, the output will be biased towards this, since it is having the highest value. Hello? So when you have something like this, y is equal to beta naught plus beta 1x, beta 2x, or beta 3x. Beta naught plus beta 1x plus beta 2x. Something like that will be having. This is a constant. So it is fine. Beta 1x will be having. This is a coefficient. It is also coefficient. So when you have a coefficient, this income values will be taken here, x1, x2, x3. So here, in that case, compared to these other values, in that case, this value is very high. In that case, it will lead to the biased output. It can be lead to the biased output. So what we will be doing, we'll simply scale the whole data. Scaling, what I'm using here, standard scalar I'm using. So we have min-max scalar as well. We have a min-max scalar. So I'll be going with standard. So what happens in standard values, standard scalars, all the values, whatever the values we'll be having here, whatever the values we'll be having here, will be converted in between minus 3.42 plus 3.4. So whatever the values that we are getting, the various inputs values will be having. So it will be converted in between minus 3.4 to plus 3.4. That is a standard scalar. When it comes to min-max scalars, all the values will be converted in between 0 to 1. All the inputs values will be converted into 0 to 1. So nx, I'm simply fitting and transforming. So these are the array of inputs we can say. And here model creation, for before getting into the model creation, what we have to do, we have to split the data into train, test. So in that we have x train, x test, and y train, y test. So it is for input variable. So it is for output variable. Target variable and the inputs that are independent variables. So I'm simply importing and I'm giving test size is equal to 20% and train size I'm given 80% of the data for the train and 20% of the data for test. So and then since I'm using the logistic regression guys here, logistic regression. Since I'm using the logistic regression, what I'm doing, I'm simply importing the model is equal to in that model variable I'm saving logistic regression random state I'm giving 100. You can give any number of values, that is random values it will be taking. So model is equal to logistic regression random values it will be taking, and in that model, so we have imported already the logistic regression at the beginning itself. We have to install it and then we have to invoke it. So in order to invoke, we can simply use model is equal to logistic regression. In that model, I am simply fitting. I am fitting X train and Y train. So train values we will be having, right? I am simply fitting it into the model. So when you fit the model and if you are predicting the output, fitting the model and then we are predicting the value. So here you can see the array of, it is a model of, model is about what? Whether that particular person going to default or not. So these are the array of outputs. So these are the array of outputs. And if you check the model accuracy score, so when you check the accuracy score, how much you got? 87% we have got. 87%. And you can see what are the coefficients. So whatever the inputs values will be having, right, with respect to their coefficient. I mean, we have seen, right, that output y is equal to beta naught plus beta 1x and beta 2x2 plus beta 3x3, something like that. So there is constant. So all these are coefficient. So those coefficient values as given here. So these are the coefficients of the inputs values. So like that, we will be doing the logistic regression implementation when it comes to real time. So yeah, this is all about the regression, guys. I hope you guys have have an understanding about the logistic regression for now. And yeah, that is it for today, guys. And if we, yeah. Yeah, that is it for today, guys. I hope you guys like that concept, the logistic regression, how it will be working, what is the mathematics behind it. Mathematics behind this, we will be having just one, that is y is equal to beta naught 1 plus beta 1, similar to the linear regression, exact linear regression. So whatever the linear regression output will be having, for that output only we are simply inputting or giving input, and then we'll be getting the probability output. So whatever the maximum probability will be having, we'll simply splitting based on the optimum value. And if it is belongs to 1, if it is greater than optimum value, in that case, we'll be considering as one class. If it is not, in that case, I'll be considering one more class. Like that, I'll be creating the classes. Like that, I'll be creating the classes at the end of the algorithm. So like that, whatever the logistic regression values will be, logistic regression model, logistic regression used as classification. The output that we are getting, it is in the continuous format only, that is probability. So that probability I am converting into the various classes. 1 class, 2 class, 3 class. Yeah. So yeah, that is it for today, guys. I hope you like this session, and if you like it, in that case, I hope you will be going through the other sessions we have covered. And yeah, that's it for today. And thank you for joining. And we'll see you in the next session with one more use case scenario. Until then, have a nice day, guys. Bye.